Hello, beautiful people. Future me. Welcome to another programming workout of mine. Let's get started. It was horrible last time. I typed in this on the typing IO, so we'll see how it goes now. Okay. Okay. That felt much better than the last one. 5%. It's not a well. It's better than the last one, so I will not complain in there. All right. So 6. Maybe I can create accounts in here. 49. Okay, currently I'm around like 50. Oh well. Okay, so what is the... Why should I create account, huh? What would be the benefit? Create account. Custom multiplier, blah blah blah. Okay, so I'll just log in with the one click, I guess. Hmm. Okay, whatever. So I will kill this timer. I will continue in the JavaScript. So here's something for me to do. And we have a resolve. So then on the next line we have a dot net. It takes the n first, then we have new promise. Resolve, set timeout. After a second, it will return 6, and we will have a six times 2, so it will go first then, second then, but they are asking about the returning type, right? So we will get fulfilled and 12, I think. Yep. First, second. Okay, the example marks a turning point in this curves. It shows that we can pass values from then to then while also waiting for slow tasks to finish. So we have a return new promise, and here we are waiting for something. And then we can do the... I don't like how it looks. Visually it's ugly. Visually is ugly. I would like to have something like console log, and then we have return, no, after, then something. This is ugly. I don't like the syntax of it. It looks ugly. It's too complicated. Basically, it means like call this and then resolve. It's ugly. Shows we can pass values from then to then while also waiting for slow task to finish. We only waited for set timeout in that example. Yeah, because it is inside of the promise constructor and they are synchronous. So we are waiting for that. So it will be first. Oh wait, it was first, second, and then we got the fulfilled, right? Or it was that, then getting this guy and then the out. Yeah, it was after that one. I can see the marks. So this one, then this one will be resolved, and then we get this guy. Okay. So example of reading from database. So it will be get author name for comment ID. Now we have a promise resolve, and we put in the comment ID. Then we have a comment ID, and we will query the database returning a promise that will resolve the comment object. So that will be return database get comment ID. So that will return, this guy will return promise. Then we have that comment. Query the database again, returning promise that will resolve to the user object. So we will return another promise, I think, yeah. And then we resolve it user, and we will return a username after that. Okay, cool. Okay, so the structure is blah something, do, return something. So it's always the then. And this should return promises. Okay. Each 10 callback is some little world. Okay, sure. Instant callback in the chain is on little world. They take an argument to do some music sucks, which I play right now. They take an argument, do some asynchronous work, and return a value which may be a promise. The first two then return the database queries. Promises, yeah, so they'll fulfill with the value returned by the database. Finally, if a database query rejects due to some kinds of failure, then that rejection will automatically flow through our entire promise chain. The idea of promises resolving to promises can be confusing at first. Oh, indeed. As with any other part of programming, it's a good idea to use simpler methods when possible. However, This is also a necessary part of any complex system that uses promises. Okay, finish. Finish him. Let's forget promises for a moment and look at the JavaScript variable scoping rules. We can declare it lit and write to it later. Sure, so this will be free. You can complicate it a bit by declaring the variable. Then writing to it from inside a function. The function can write to the variable as long as the variable is in the function scopes. Yeah. Okay, so this will be free. We have a declaration of the variable. Then we have a declaration of the function. And then we call that function and read the num. We can do the same trick with the promise constructor's resolve argument. That allows us to capture the resolve function, then use it outside for the new promise. We can do the same trick with the promise constructor's resolve argument that allows us to capture the resolve function, then use it outside of the new The resolve variable now contains the function. Okay, let resolve, then resolve equals R. Then we call it. Okay, so we took it out, we assigned it to it. Okay, and it will be fulfilled free. That's weird. Okay, so we define it outside. Then we assign it inside the promise constructor in here. And then we call it outside. The resolve variable now contains the function that we got from the new promise constructor, calling it will fulfill the promise, even though it now looks like resolve and promise are unrelated. Okay. resolve. In that case, we assign the argument to itself rather than assign it to the let resolve. Yeah, well, sure, that makes sense. Another chance for us to see just how asynchronous promises are. We can. Yes, we can. Store the resolve function for later. Attach tens to the promise, even though we haven't called the resolve yet. Okay. Use set timeout to wait for a while. Then call resolve, which will fulfill the promise and cause tens to begin. Okay, so I try to imagine how it will be now. When I press this, it will show us what I mean, right? But I will try to guess. So first, I will basically do this guy. I will take the resolve outside. Then on the promise, I'll say promise dot then multiple things. I can do it in here or over there, I think. And then I can call the resolve. And the timeout to wait for a while, so it will be somewhere in here, for example. So what they did, resolve, resolve. Yeah, so now we take it out. Then we have dot then we set a timeout. Then we resolve it with free. Oh, cool. So we take this free that goes here, free, and now it will be 6, and it will be fulfilled. Oh my god. Fulfilled 6. It's jumping all over the place. So I'm not sure how much readable that is, but I'm kind of happy that I can understand it now. So once again, resolve. We steal the resolve in here. We attach then to it. Then synchronously, we just set timeout. After the timeout, after 1 second, we call the resolve with free. Free will returns are fulfilled. Dot then takes that fulfilled value and put it inside of here, so it will be 3 times 2 is 6. And we will have, in the promise, we will have this guy. The net effect of this is can split promises into two pieces. We might pass the resolve function to one part of the system. To one part of the system? What do you mean to one part of the system? We can pass it to one part of the system. Then pass the promise itself to totally different part. When the reading side tries to look inside of your promise with a, then it will have to wait until writing side call the resolve. Okay. code for me to complete. Use new promise to assign the promise constructors to resolve function to the variable resolve. Okay, so resolve, new promise, and it was R, and resolve equals R, like so, and that should be it, really. Yep. One important note about the promise constructor: can only resolve to a promise once. Sure. The promise fulfills with the first value passed to resolve. All other calls are ignored. Okay, to resolve are ignored. So we have split promise, the function. We have the resolve. Then we have the promise. And we return this array. Okay, so resolve and promise is split promise. Okay, so we deconstruct that in there. Now we have resolve 531. It will just do the first one, and promise.then will get 5 times 2, that will 10. So fulfilled, like so. A couple of final notes. First, this lesson shows us why the new promise constructor's callback is called synchronously. Imagine an alternative universe where the callback is called asynchronously. In that case, the resolve call below would have the resolve call would happen before a resolve is even assigned. Yeah, I got it. So resolve, we just extract it and then we call it with nothing, so it will be fulfilled undefined. Right. Why do you show me this piece of code? Second, here's a quick example. Or that just goes to this, I guess. Second, here's a quick example of how we use this technique in execute program itself. You might have noticed that some code examples say wait up to 3000 milliseconds, yeah? But they often finish much faster. That's because we track every promise and timer created as the example runs. If the promises and timers all finish before 3000 milliseconds, we end the example early because there's nothing else to wait for. So track it. How do you track it? Here's the top of executes program internal set timeout function. It does its own internal bookkeeping to track the timer, then later calls the browser's built-in set timeout. The two lines in the body of this function should look familiar. Two lines in the body. So we have a promises, then the set timeout here is callback, milliseconds, and arguments. It takes arguments. Hey, we store a promise that resolves when the timeout fires. This let us wait for an example's timeouts later. Let resolve. Yeah, okay, so they stole it, the resolve from the promises. And promises push. Okay, so they have an array of promises. Okay, we store promises resolves when this that resolves when timeout fires. This let us wait for an example timeouts later. Not shown code using browser's built-in set timeout to set up a timer that calls both callback and resolve. Okay. Yay! 23 seconds. Catching promise rejections. Cool, look at all of those things I did, and we have still 4 locked. 1, 2, 3, 4. In regular JavaScript. Oh, and we are over the time limit, which means we are done. Done is better than perfect. And I'll see you next time.